Hey everyone, welcome back to the channel. Today we've got some exciting news and an update on our Acura Legend. As you know, if you've watched our two previous videos in the series, we had a head gasket issue with our Acura Legend, which required us to tear it down and send off the heads to the machine shop to get reserviced. Well, in that, we've got a final report that I'd like to go over with you, share some of the details of the machine shop work, as well as give you a glimpse at what they look like before we start to put back everything together. We still got a lot of work before we get to the point of reassembly, and we're going to take our time and make sure it's done right. And we'll show you all the steps that we're going to take along the way. But let's go ahead and break down what actually happened with our Acura Legend and what is it that we want you to take away so that when you think that you might have a head gasket leak, what you might want to think about in the near future.
All right, so let's go over what the machine shop said about our head gasket and what they think was the contributing causes or the causation for a head gasket failure. So this is the passenger side bank of cylinders. That's cylinder number 1, cylinder number 2, and cylinder number 3. Now we know from when we took the head gasket off that there was likely an issue around cylinder number 3. I asked them to take a look at the heads and the head gaskets on both sides and tell me what their opinion was. And in their professional opinion and assessment, they said that the cooling portion of the head gasket, where it separates the coolant passages to the cylinder, had failed, and that was really obvious by the crack. Now, we also can back that up with evidence that we know there was some coolant or water in the number 3 cylinder, and it caused a little bit of cylinder wall corrosion there. Very minor, and in their professional opinion, didn't need to have any other work done to put the engine back into service. So good sign there. We know where it was, and we know that there was no long-lasting damage on that cylinder wall. So what was their professional opinion on what caused the head gasket failure? So let's go ahead and get into that. So in their professional opinion, what they shared with me was that it was an overheating event or series of events and insufficient clamping force on that graphite head gasket. They noted that graphite head gaskets are very pliable, flexible, if you will, and when you add heat to that equation and a lack of clamping force, whenever you have an overheating event on top of that, it weakens the head gasket significantly and can expedite its failure. So we do know that we had a series of issues with the cooling system on this car. We had a blown thermostat, we had fans that weren't operating correctly, we had radiator issues, and all of those probably contributed to a fast-paced failure of the number 3 head gasket. So in their professional opinion, they said that it was an overheating event, either one significant event or a number of small events that added up over time, plus insufficient clamping force on that head. So I asked a couple of other questions based on community knowledge, so let's hear what they have to say about that. So the first question I asked them was, in their professional opinion, was the head gasket failed due to pre-detonation in the cylinder? And in their professional opinion, they saw no signs or evidence of pre-detonation on that cylinder. So that is one theory that people believe in the community contributes to head gasket failures. So in their professional opinion, with my car, my engine, my situation, there was no sign of pre-detonation and no contributing issue to the head gasket failure when it relates to pre-detonation. The next question I asked them was, what about the EGR system? Do you think in any way that a failed EGR system or a clogged EGR system would have contributed to this head gasket failure that you saw on my car? And they said, in no way did they believe that there was an EGR system failure here, nor did they believe that there was any evidence that suggested that an EGR system caused failure with my engine. And to add to that, they said that they delete EGR systems all the time on cars. They're very familiar with the Acura Legend and NSX head gasket failures, and they thought that it was a zero possibility that the EGR system would cause a head gasket failure. So that's contrary to what we know in the community, and I share that not to say anything other than in my example, there was no evidence of an EGR system, causing the head gasket failure. The next question I asked them was, well, what can I do to prevent this issue from happening again? And they said, in their professional opinion, if you can't get an MLS gasket, a multi-layer steel gasket, then you want to do two things. The first thing is solve any cooling issues right away. And if you can, create some cooling capacity above what the OEM spec and manufacturer has provided. So larger radiator, more CFMs from the fan, a lower thermostat so that it opens up sooner, a number of things that you could do in that realm to increase the ability for the engine to cool and cool faster would help in this situation. The next thing that they said was increase the clamping force if you can on this engine so that as materials heat up and expand, you're not causing extra strain on that graphite gasket. They said if you can get ARP head bolts or head studs, that way you can really clamp down on the head to the block more sufficiently and create that larger surface area clamping force on the head gasket. And I said, knowing the cost of ARP head studs, what about the OEM ones? And they said, well, if they're torque to yield, you definitely need to replace them. But if they're not torque to yield and they're not on the Acura Legend, you can reuse the head bolts because they're not torque to yield. They said, add a couple extra foot-pounds of torque to those bolts so that you actually create a larger surface area of clamping on that head gasket, and as materials heat up, there'll be a little extra pressure to help you in those situations. I said it's probably better to go ARP to avoid this from happening again, but if you go 4 pounds of pressure over the manufacturer spec, which is 56 foot-pounds, so we would be going to about 60 foot-pounds, you can go ahead and create essentially a little bit more pressure on that head gasket. They also recommended, like the book, to oil the threads, oil the washers, make sure that you have the correct torque, make sure you're using a torque wrench that is accurate so that you don't accidentally strip the head when you go to reinstall it. So there you go. There's just one example of an Acura Legend head gasket failure with an analysis from an expert in machine shop and engine building, giving us an assessment of what happened with our engine. We'll go ahead and take that information and knowledge, pair it up with what we know from the book, and go ahead and put a new set of head gaskets on there, and we'll get this car back on the road and hopefully strengthen its longevity and remedy any head gasket failures from occurring in the future. So let's go ahead and get back to work on this engine and reassemble it. All right, here's my solution for the heat management of this wire harness for the NOx sensors. They go here and here, and you can see that this is a wrap that goes around the wires and is designed specifically to insulate it against heat. So let me show you what this product is. This product is a foil that obviously reflects heat, but it also has a ceramic inner liner to it. This is what really will protect that wire harness long term. This is the same stuff that you'll find on like stoves, like pellet stoves and wood stoves that try to keep a seal between the inside and outside. So like the inside of the stove to the outside in the environment of your house. It's the same material, so it's pretty suited for this type of application. And it was really inexpensive too. I think the whole huge thing that I have here and then what I've used there ended up costing me no more than like 10 bucks. But it's far better and will last longer than the plastic pieces that Honda put in there. It's also going to provide a continuous protection layer as opposed to just what they did, which was electrical tape some plastic bits to it, and then obviously it didn't last long term. So we're actually using a better material. It's going to last longer and overall is going to suit this application. All right, so part of the journey here is restoring some OEM parts that we can't obtain anymore. This is the heat shield off the exhaust manifold, and you can see all this baked on oil. This is a result of the valve cover gaskets just leaking and dumping onto the heat shield. We've resolved the gasket issue and put a new gasket on there, but we weren't able to get to this until just now. Now we're going to restore this, make it look brand new. Put in here, and then I used some Scotch-Brite pads and a combination of the razor blade to get some of it off, and then I came back with a really fine Scotch-Brite to take out all the heavy scratch lines. But that's how we can take things like this and restore it to its former glory. Pretty simple, inexpensive, but makes a huge difference in the end. Okay, so we have the intake manifold taken apart here. Pretty simple process. You remove the bottom. So this is the bottom, that's the top. And you can see it's pretty clean in here. Pretty clean for 133,000 miles, I can tell you that. So not a lot of work here. We're going to get this all cleaned up, put it back together, and we'll get on our way to reassembly here. Pretty simple process, just a couple of bolts here. I think they're 12 millimeter heads, so if you can get this off, you can take this apart pretty easily. You'll want a new gasket set, obviously. Replace your hoses while you're in there, and you'll be on your way. All right, I want to show everybody something real quick. So this is my intake manifold, freshly disassembled off my car. I want you to take note of all of the conditions, right? Look at that. Okay, so ask yourself one question. What is the common prevailing theory in the legend community about bad head gaskets? It's always linked to EGR. Everybody says that the EGR gets choked out, and then what happens is that the head gasket goes because the EGR system has been choked out. I want to be very clear that this is OEM. Like, all these hoses are OEM, all these gaskets are OEM. Nobody has taken this apart. This car has 133,000 miles on it. And I've talked to the original owner, so this is a one family car. Nobody has taken this apart. That EGR and this right here is 100% clean. Yeah, there's some residue in there, but there's no buildup. So why did my head gasket fail, right? Because that's the theory, is that the EGR system gets choked out, and then all of a sudden you have a bad head gasket. I have never really fully subscribed to that theory, but I can tell you one thing. When we look at the graphite gasket, and I'll pull it out of the trash here again real quick. I'm not even going to edit this video. I'm just going to go with it live like this. That's where, right there, there's a little crack right there. But more specifically, it's herniated. And it's the back cylinder, like it always is. I have always said that the issues with the Acura Legends 3.2 liter C-Series engine is multifactorial. And the reason why I say multifactorial is because when you look at that gasket and it's herniated like that, that tells me two things. That the graphite compound used in the head gasket swelled and herniated, and that usually only happens for two reasons. One is you get too much pressure, or two, you get too much heat in there, which expands it, and then it ends up fracturing. Graphite compounded head gaskets typically only last about 200,000 miles too, so take that into consideration. With this being as clean as it is, as low mileage as this car is, I believe the issue with this had to do with the video I did on repairing the cooling system, more specifically the cooling fan modules and how my cooling fans weren't operating correctly. Additionally, the thermostat on this car had a problem too and was stuck open. Well, we don't know what happened after it failed. We don't know if there was a buildup of pressure, buildup of heat, and then the head gasket herniated. So poor maintenance likely led to that thermostat going, but also we have a cooling fan issue that we've got documented on this channel. All right, let's go ahead and show you what a hydraulic tappet is and why we have to remove them, along with kind of the technique that I've applied to this to get this done. So here's what we have when we say hydraulic tappets. These are oil-filled, and what they do is they sit into the rocker arms here and then go against the camshaft lobes so that there is a very smooth engagement with the camshaft and the rocker arm assembly here so that you have a very quiet valve train. Some use hydraulic, some use solid lifters to do that. Either way, what we have to do is we have to remove these, and if you look at the end of this, there is a little black O-ring that goes at the top of those. This really ensures that there's a good seal there so that when oil comes through the passages and enters into the top here, that this fills and also fills so that it like has this movement and kind of firms up as well. So that with oil in it, it will firm up. Without oil, you'll get this. This is also what leads to that valve train noise. If the oil is not able to move freely throughout the tappet and you have some buildup of like old oil, you'll get some resistance here, which leads to your valve train noise. So you want to make sure that these O-rings are replaced, but they're a little tricky to get out, and here's why they are. So let's go ahead and take a look at one over here. So there's that tappet, it's right at the end. But there's really nothing to grab onto there. It's really difficult to get that out. They don't just fall out either. They're really engaged in there with that O-ring. So as they're sitting in there, you have to figure out how to get something to get that out. And the best thing that I found to get that out is a pair of these. So these are pretty inexpensive cobalt, adjustable and lockable wrenches or pliers, whichever way this you want to call this. But you can see here that I can press this button and I can dial it in to the appropriate size. So what I did was I matched the size here of my hydraulic tappet. And you want to use something that's smooth. You can see that there's no teeth on this whatsoever. It's just a smooth. And the metal used here is harder than the metal you used to make this tool. So you can see that it's starting to mar a little bit by the job I'm doing. These are brand new. I just purchased these specifically for this. But with this dialed into the specific diameter of these hydraulic tappets, I can grab onto these without fear of really damaging these in any way by crushing them. I got a nice firm grip on there, and then I can wiggle them out. So let's go ahead and show you how that's done here in just a second. Okay, so I've got my valve train here, my rocker arm assembly, and I've got my wrench dialed into the specific diameter for this hydraulic tappet. You can see here, here's a very small end that I'm having to hold on to. But if I was to hold on to it like this and just rock it back and forth, and that's okay because these are softer than the metal and these are covered in oil, so you really want to try to get a good grip on this if you can, and really just try to work it by pulling on it a little bit at a time. And it's going to take some work to get this out. It's not going to be easy. I'm putting a fair amount of pressure on this and it's still not coming out. There it goes. So there we are. Yep. Not a single damage done when I slipped off of it, but we got that out. So that's how you go about doing this very easily without damaging anything. So we'll go ahead and get them all removed here, and then we'll go ahead and show you how to bleed these in just a moment. All right, everyone, we've got all of the hydraulic tappets out of the rocker arm assembly. And now what we need to do is go ahead and clean them up and go ahead and bleed them. So the first part is that we want to make sure that all the old oil is out of these. And there's a little check ball valve inside there. It's really hard to show you, not going to be able to, but just trust me. These serve as a reservoir for oil to fill it up and provide some cushioning power to the rocker arm assembly. This really leads to a quiet valve train assembly because it's riding on that volume of fluid. But what we need to do is clean these up, get the caked up oil that's in these out so that they function and fill correctly. And we need to replace all the O-rings on them, such as this one right here, and we're going to do that with a simple pick. After we go ahead and clean these up, we're going to go ahead and bag them, label them for a future point where we're going to go ahead and bleed these. So we're going to dip these in oil. We're going to push down on that check valve that's in there, that check ball that's in there. Make sure that we get all the air out of that, put a new seal on there, and reinsert them into the rocker arm assembly. So key feature to making sure that we're rebuilding this better. I'm going to go ahead and put some brake fluid cleaner in this. We're going to go ahead and make sure we agitate it a little bit, get all that fluid out of there, allow it to dry properly, and then bag it. So just give you an example of what I'm talking about. As we go ahead and get all the old oil out of these tappets, we're discovering that the oil is super thick, which means that the oil has been really heat cycled over and over again to the point where the viscosity has thickened, and this is what gums up the internal mechanism of those valves, because the oil is then caked up and the check valve isn't able to operate efficiently and allow the oil to fill, and we get a little bit of a leakage occurring. So this is really some good preventative maintenance to ensure that the tappets don't wear down prematurely. As you look at the tappets, they have a wear mark on them, but if they get too damaged, meaning too much wear, you'll have to replace them. So this is really ensuring that we get some of that old oil out, ensure the functionality of it, and also refill it with the proper weighted oil. So that's 10W30 per the manufacturer. We're going to go ahead and add 10W30 to these when we go ahead and bleed them, and that will ensure that the valve mechanism within the tappet is actually going to function smoothly and efficiently. Along with the new O-rings that we're going to install, that will make sure that they have the opportunity to seat correctly and receive that oil as the pressure builds up. So as the pressure builds up, the oil enters the check valve, it bypasses the check valve, it fills it, and then when the engine turns off, it should stay filled. As the operation of the engine occurs, it should get recycled and replenished while it's building that pressure. If the O-rings aren't seated properly, or if they've failed because of age, the oil won't actually build pressure in that tappet, and that's when you get that valve train noise that we're so familiar with as Legend owners. All right, so we've got our rocker arm assembly here. Now what we need to do is go ahead and break this all down and go ahead and clean it and re-lube it. And we're going to use our assembly lube here to go ahead and do that. All contact points should, for that initial start, have a nice thick layer of assembly lube here so that we make sure that we're not causing any wear on the rocker arm assembly, which is a moving assembly. So that's important. We'll go ahead and make sure everything is moving free. Key note here is these bolts right here, all the black colored bolts, not the light colored bolts here, all hold this assembly together. So as you take it out of the car, you want to make sure that these are in place. For disassembly, you break it all down by removing the bolts and then take everything off and create an assembly line is my recommendation. So as you break it off, make sure that you lay it out in order from left to, or from right to left, and then make sure that you clean each part from right to left and then assemble left to right. That'll make sure that everything is cleaned and lubricated and you're able to put it back into its configuration without messing up anything. Once you have everything locked in and cleaned and lubricated, slide your bolts in as you're reassembling everything. That'll make sure assembly goes smoothly, and you can also check for resistance in all of your moving rocker arms here. After we do that, then we can insert our hydraulic tappets. But for right now, we're just going to get this broken down and get it cleaned. So, quick introduction to what a head looks like after you get it back from the machine shop. So, this is our head right here. You can see it's all nice and clean, and that's because they jet wash this head, which is basically just a high pressure water cleaning out all of the gunk and oil residue that's been built up over the years and all the miles. So that's just kind of what they do in general to start the process. Next, they're going to go ahead and disassemble everything. So we give them the heads looking like this with the rocker arms and the camshaft removed. And then what they do is they take all the valves out by removing the keepers here by pressing down on the spring, remove those keepers. They drop the valves out and they remove the seal along with the spring. So it kind of comes apart in a couple pieces there. They go ahead and do an assessment, pressure check everything. They also deck the head, so they basically take a little fine layer of material off the bottom here where it meets the head. That allows for that nice, smooth, clean surface. It also takes out any potential warping that may have occurred due to like overheating conditions. And thankfully, the machine shop told us that we really didn't have any warping related to overheating. So they had the ability to just remove, or had the capability of just removing a few hundredth of a inch of material so that then they could smooth out those heads. Now we got to clean up things a little bit, so the surface is going to be covered in like oil that needs to come off with some lacquer thinner. That's pretty easy. We got to do the same thing on the head, on the block side as well. But so this is just generally what they do. And then when they reassemble everything, and in our case, we ask them to do a valve job. And if you take a look at the bottom of your head, you'll notice that they've got a surface for each little valve. Well, where that valve meets the head, they have the ability to really make it a tight seal. Over the years of driving, you'll have a degrading of the surface to surface contact between the head material and the valves, which will cause a little bit of leakage. And since we had a little bit of compression lowering on one side of the engine, they really highlighted to us that there was some contact issues. And so, if you pair the two together, it makes sense to have a valve job done. So we had a valve job. We also replaced the valve stem seals. So the seals come up and they have like a little rubber gasket, if you will. It's round and it slides over it. That prevents the oil from the head leaking into your cylinders and burning. So that's always advisable to replace those while you're having a valve job. The other thing is that they hone the valve stem seal, or the valve stems themselves, so that you have a nice smooth contact between the seal and the valve itself. So we had them do that. Next, what we have to do is put some engine assembly lube everywhere contact point, so that when we start the engine for the first time, it comes lubricated. And what we're going to use is Lucas Assembly Lube. This is a really nice product and will ensure that when we start the engine for the first time, we've got good amount of lubrication to reduce wear on our camshaft, which is right here. The other thing, so the theme here is clean and re-lubricate, right? So we had to clean our camshaft and we cleaned our rocker assembly, and we'll show some video of us taking this apart and cleaning it all up. But what you have to do is all of these bolts hold everything together, and you want to take everything apart, especially if you have it sitting in an environment where things like this can get introduced. Not to say that we don't keep a pretty clean environment, but things just happen and they'll fall into the cracks of this assembly. So before you go reassemble everything, make sure you clean it, because even that littlest bit of sand or salt material or whatever it is that could get in there, it could eat away and destroy your rocker arm assembly or your camshaft or the valley in which it sits in. So best thing to do is just take it all apart, clean it, and put it back together with your engine assembly lube. Now you can use regular motor oil, but it's not thick enough, and so it ends up seeping out over time. So if you were going to do a real quick engine assembly or head assembly, you could do that, but we're still working away at this very slowly. The other thing that you want to take note of is that each of the areas where these spark plug holes are, at the bottom of it, they have a gasket. And so you want to make sure that you have new gaskets ready. We have our gaskets right here ready to go in, and they kind of sit in there really tightly, so you don't have to worry about them falling out as you do reassembly. But that's just in general some things that you want to do.